Hello everybody, and welcome to exercise 2 on page 20 of the workbook here. Let's take a minute to read this question together. So the volume of water in a leaking tank is given by the function v equals f of t gallons, where t represents time in minutes. A graph of the function f is given to the right over here. Okay, so let's just kind of take stock of what we have in our graph first of all. So we've got V on the vertical axis. That's measuring our volume in the tank in gallons. Okay, and then over on the horizontal axis, we've got time in minutes that we're talking about. You can see from the graph that the volume is getting smaller as time goes on, just reflecting the fact that this tank is leaking like the problem was telling us. Okay, and what they'd like us to do is to estimate a couple of rates of change. Okay, so if we start with A here, they'd like us to estimate the rate at which water is leaking from the tank at t equals 3 minutes. Okay, so this is asking us for an instantaneous rate of change of this function at a point. And we talked on the previous page about how finding that instantaneous rate of change is about finding the slope of the tangent line graphically. And in particular, it's going to be the slope of the tangent line at t equals 3. Let's maybe start by drawing in that tangent line. Okay, so t equals 3 is sitting down here. Okay, and if we find the point that's at t equals 3, it would be right there. Okay, and you can't see this, but I'm taking out a ruler now, and I'm going to draw my best approximation of what the tangent line looks like there. Okay, so something like that maybe. Okay, so we want the tangent, the line that just kind of grazes our curve at that point. All right, well, to find this rate of change, we need to find the slope of that line that we just drew. Okay, and I'm going to remind you of what we're calculating here. We are looking for the derivative. Remember, that symbol represents the slope of the tangent line at 3. And we can find that slope, we can find that derivative by estimating the slope of the line that we just drew in. Okay, now there's only one problem here. How do we do that? Okay, we're not given a formula for our function, just a graph. And so we have to think about this problem strictly graphically. How do we find the slope of this line that we drew? Okay, well, one way would just be to pick 2 points on the line. Okay, starting with this point. Okay, if you look at the scale, you can see that that point is at 3, and then 10,000 looks to be the y-coordinate. And I'm just going to try to pick a second point on this line that's reasonably nice, maybe down here. You wouldn't have to pick that point, just any other point on the line will do. And if we guess the coordinates there, it looks to me like that's about 18 and 1,000 on the scale. Okay, we're just going to use those 2 points and find the rise over the run. So the difference between the y values of those 2 points would be 1,000 minus 10,000. Okay, and then the difference in the x-coordinates, that's going to be 18 minus 3. Okay, and you can do that calculation. Okay, if you calculate that fraction, you're going to get negative 600. And my question to you would be, what are the units on that number that we just calculated? Okay, well, think about the units in the numerator and the denominator. So these 2 numbers that I'm circling, those were gallons. And these 2 numbers were minutes. So we should be talking about units of gallons per minute here. Makes sense, because what we're trying to calculate is a rate of change. So, in words, we could say that the tank is leaking at a rate of 600 gallons per minute at t equals 3 minutes. Okay, so that's what the slope of that tangent line is doing for us. It's giving us a rate of change. Okay, and if you like, you could maybe pause the video at this point and see if you can do part B. It's asking you the same question, just at a different point here. T equals 18 minutes. Okay, so give that a try. Welcome back. Okay, so hopefully you tried part B on your own here. We're going to work through that together, and you can compare the answer that we get with whatever number you got. Okay, so estimating the rate of leaking at t equals 18 minutes just means we're going to try to draw in the tangent line to the function at t equals 18, which means that we're there. And so we need a tangent line that goes through that point. So I'm taking out my ruler. Again, you can't see it, but you will see the tangent line appear in just a second here. Okay, there's my best attempt at drawing the tangent line at t equals 18. And so part B is asking us for the rate of change at t equals 18. That's the derivative. And to get it, we need the slope of the line that we just drew in. So I'm going to use the same strategy that we did before. Pick 2 points on the line. This point looks to be 18,300. Okay, and I'm going to try to just pick a second point on that line. This point over here looks to be reasonably nice. Okay, and notice that that point has coordinates of about 3 and 8,000. Okay, we're just going to calculate the rise over the run between this point and this point. All right, so let's see. The difference in the y coordinates is going to be 3,000 minus 8,000. Okay, and then the difference between the x coordinates is 18 minus 3. All right, and if you do that calculation, you're going to get negative 333. Units, again, are going to be gallons per minute, rise over run. And so we have just calculated the leak rate at t equals 18 minutes. Okay, and you could maybe ask yourself, now that we've finished this problem, where are we getting the fastest leak rate? At t equals 3 minutes or t equals 18 minutes? You can see from our number, we're getting a faster rate of decrease at A, negative 600 gallons, and that makes sense because you can look at the 2 lines we drew and see that we have a steeper line at t equals 3. Okay, that line is steeper, and so we're getting a steeper negative slope there.